All right, now we're going to be looking at present value of an annuity. So remember, before we were trying to find the future value. Now we're going to try and find the present value of a future known amount. So how much do I need to start depositing every week or every month or every year so that I can get that future value that I want in the future? And that's kind of what we're going to look at in this. So let me share my screen here and I'll get to those problems. I should have probably did all that before I started my video, but let's see. So we're going to be looking at future value. So this is Broadway Movieplex. I can find that one. There it is. Okay. So this is looking at present value. And I'll show you how you can tell which one you're dealing with here. All right. So looking at the problem, it says that Broadway Movieplex needs 20,000 at the end of each 6-month movie season. So 6 months from now, they need $20,000. So that is, they're giving me a future value. So now I'm going to find the present value, and it's going to tell me why in a minute. At the end of each 6-month movie season for renovations and new projection equipment, how much must be deposited now? So that tells you right off the bat, this is a present value problem. I'm looking for the present value. It's going to be less than that future value. So how much is that present value now? That means I need to use chart 12.2, which is present value on a ordinary annuity. So if I'm looking for future value, I use table 12.1. If I'm seeking present value, I'm going to use table 12.2. So again, we just kind of do the same business here. We're going to be doing this semi-annually at 8% interest. So again, semi-annual means 2 times a year. So if the interest rate is 8%, I'm going to divide that by 2, which equals 4%. And then if it is the end of each 6-month season, for how long does it say? So for 6 years, 6 years. So I'm going to multiply that by 2. So that means 12. So 12, it's at the end of each year. So that means it's an ordinary annuity.
Mr. Touchette.
Yeah.
We can't see you working out the problem.
Oh, I'm sorry. I'm still sharing that screen. Hold on a second. Thank you for letting me know.
Mm-hmm.
I shared it, but then I didn't share my screen with you guys. So you guys are looking at me work it out. It's like, ah. All right. Sorry about that. All right. This is the only problem. I'm still trying to figure out what's the best way to do this because it is clunky. I might have lost everything I just did, but that's okay. I can just do it again. All right, I apologize. We'll just start over. So again, it's saying here that at the end of the month, so that means it's an ordinary, right? And then it says they need 20,000 at the end. And then right here, it says how much must be deposited now. So that tells us they're looking for present value. We have the future value. The future value is they need 20,000 in 6 months or at the end of each 6 months. So they're looking for some money. They want to know how much they need to put now to get that $20,000. So again, just like we've solved all the problems, it's compounded semi-annually. So that means 2 times a year. So 8% divided by 2 equals 4%. And then it's going to be for 6 years. So that's going to be multiplied by 4. So that means it's going to be 24 periods at 4%. So this time I'm going to go to the table 12.2 because I'm looking for the present value. Before I was looking for the future value. Now I'm looking for the present value. So if I go on page, and I apologize that I can't show this to you, but if you go to page 382 and 383 in the 8th edition of the book, it's also, by the way, listed in the check-in assignment at the bottom and on the formula page. It's not on the check-in assignment, but it's in the formula page. If you go there, we're going to go 24 periods at 4% interest. So 24 periods, 4% interest comes out to 15. Hold on a second. 15,256. So we did some. Oh, sorry. 6 years times 2. I did that wrong. It wasn't 4 times a year. It was 2 times a year. So that would be 12. I knew something didn't look right. You guys with me still? Okay. 12 times 4% comes out to 938,507. That's the table factor. 12 at 4% is 9 0.38507. And then I would multiply that by the amount that they need equals $187,701.40. So that is how much they're going to need total at the end of, so they're saying 20,000 at every 6 months. So again, I would have to take the 20,000 times 2, which would be 40,000 a year. And then I would times that by 6. So 6 times 4 is 240,000 is what they're hoping to get. That's what they're hoping to have. So what they need to deposit then between now and in those payments every 6 months is $187,040 or $701.40. So that would be the present value of that 240,000 that they need. Is there any more to that question? Oh no, this is not a Sienna question. All right, next question. Any questions on that? Does that make sense to you guys? Okay, you could also divide this amount by the 24. And that would give you how much they have to deposit every time. So I don't know if it's asking for that. What's the question asking for? To yield this annuity, how much must each deposit now at 8% confidence? Okay, yeah, so we should have divided the 187,701.40 by 24. So let me do that. Sorry about that. I didn't finish the question. I just got to that point and I stopped. But if you take the 187,701.40 and you divide that by the 24 periods, which you'll be depositing, you need to deposit $7,820.89. So that's what you need to deposit every time that you, every 6 months, you need to deposit that amount with compound interest. It will earn at the end that 240,000 that you need. So the present value of the 240 is 187,701. That's the present value of the 240,000, but to do it in payments, you must put in every 6 months $7,820.89. So that's really the answer to the question. Are you guys with me on that? Did I confuse you? We're gonna do another one. So you guys all right? All right. The next one is we're going to be solving for, you're an accountant at Supreme Lumber Inc. Company based on sales expense forecast. You have estimated $10,000 must be sent to the Internal Revenue Service for income tax payments at the beginning of each month for a 3-year period for the next 3 years. So if you wanted to again go be 4 times a year, you'd have to pay 10,000. So it'd be 40,000 a year for the next 3 years would end up being 120,000. So that's total what you're hoping to get. You're hoping to have that 120,000 over the next 3 years by putting in 10,000 every 3 months at the beginning. So the beginning is what? That's an annuity due. So how much must be deposited now? There's your, that means to use 12/2 at 6% compounded quarterly to yield that annuity payment. So we're going to take the 6% and we're going to divide that by 4 because quarterly means 4 times a year. So that's going to be 1.5% each time I compound it. And then it says here it's going to be compounded quarterly for 3 years, right? So 3 years divide or times 4 equals 12. So there's going to be 12 periods at 1.5% interest. However, in last time, if you remember, when we did an annuity due, we had to add 1 period. But when you're doing a present value, you have to subtract 1 period. So in this case, it would be -1 equals 11 periods. So that's what I would go to on the table chart. I would go to 11 periods at 1.5%. And if I do that, the table factor on 12/2, 12/2 is the factor, or the table, it's going to give me an amount of 10,000.07112. Now, just like we did on an annuity due on a future value, we subtracted 1 in this case, and remember, we added one to the periods and we subtracted 1.0 from the total. In this case, we're actually going to add 1. So just the opposite of when we're doing it for a future value. When you're doing it for a present value, you have to add 1. So the table factor now changes to 11,702, and you multiply that by the 10,000 in this case. And basically the present value of that is going to be $110,711.20. So that's the present value of the 120,000 that you're going to need in 3 years. So again, if you want to figure out, well, what is the annuity payment needed, I would just take this and I would divide that by how many periods it was. So I believe it's by 12, because that's how many times you're going to do it. So divided by 12, 110. I didn't do the math on that either. So 110, 711, 70 divided by 12 equals, sorry, I didn't do it right, 110,711.70, was it? 0.20, sorry, divided by 12 equals $9,225.93. So that means I need every 3 months I need to deposit $9,225.93, and with compound interest over the next 3 years, I will have $120,000 to pay the IRS. So that's present value. Again, if it says how much now, I'm going to use present value process. If it says how much then or in the future, then I'm going to be using the future value. Let's go to the problem in our book, or excuse me, our problem in our check-in assignment with Sienna. So I'm going to get out of here and I'm going to share that screen with you guys. So hold on just a second. I don't know if I have this one. I might have to go to the other. For some reason, they all didn't load for me. Oh, here it is. This is it. All right. So we're going to share that. Easy teach. All right, you guys there? Can you guys see that?
Yeah.
As part of an inheritance, Katrina Jackson will receive an annuity of $2,000 at the end. So what does that mean if it's at the end? It's an ordinary annuity. That makes it easy. The end of each year, so it's going to be 1 year, compounded yearly for 10 years. So that's going to mean it's 10 periods, right? If it's every year. And then it's going to be at 6% interest. And so since it's 6%, it's going to remain 6%. So I need to go to my chart. I need to look up my table factor for 6% for 10 years. And because it's an ordinary annuity, I don't have to add or subtract anything. It's going to be whatever the table factor is. So table factor is 7.36009. I multiply that by the 2,000 that they're going to be putting in every time, every payment. She's going to have $14,770.18. So that's how much she has to put in. Now, again, if you take the 2,000 times 10 is 20,000, right? That's how much she's going to have to put in. That's how much she will put in over the next 10 years, because at the end of every year, she's going to put in 2,000. So the next 10 years, she's going to put 20,000 in, but she really only needs to put 14,770. So if you want to look at how much difference there is, you can subtract the two. Which means that she earned that much interest, whatever that comes out to. So what is that like? I don't want to risk it. I'm just going to do it. 20,000 minus 114,770 and 18 cents. So she earned $5,229.82 in interest. Or if you want to figure out how much she needs to put in every year, you would take the 14,770, 18. That's how much she needs to put in, and divide that by 10. because she's doing it 10 times once every year. Divided by 10 equals $1,477.07. So that means every time that she makes a deposit into her annuity over the 10 years, at the end of each period, each year, she's asked to put $1,477.07 to give her in the end the $20,000 that she's going to need. All right. So I worked out those present value problems. Now I'm going to do one more in this chapter, and that is the sinking fund.